All right, everyone. Welcome to another homework session. This is chapter 3, homework number 5. All right, so starting on number 3-55, number 55. Right. So this one says Loris has created the following challenge for you. She has given you 3 of the 4 points necessary to determine a rectangle on a graph. She wants you to find the points that complete each of the rectangles below, and then calculate the area of the rectangles formed. Okay, so first we gotta make the rectangle. So let me see. Wow. Okay. I thought I could zoom in a little bit more, but all right. So for part A, okay, we are gonna graph these 3 points. So that first point is -1, 3. So you can go on here. -1 and 3 is right there. Okay. Next point is -1 and 2. -1 and 2 is right below that. So right there. And then the next one is 9 and 2. So if you count 9 this way, that's all the way to 9 and 2. You have right here. Right. So that's the third point. Now you need a fourth point, and the fourth point is just whatever point it is that that completes this rectangle, and you can clearly see on the graph if you connect the dots from there to there. Okay, I would need a dot right there, right? So the fourth point should be 9, comma 3, where x is 9, y is 3. Right. So that fourth point should be right there, and then if you connect the dots, you will get a rectangle. Okay, so that's the first part. So what you need was the fourth point, which is 9 comma 3. So that's the first part of the answer. And the second part is, what's the area of this rectangle? So the area of this rectangle, I'll put it right here. So area is going to be the base times the height, or the length times the width, however you might have learned it. Okay, I'm going to go with base times height. So the base of this rectangle is, how long is this base here? How long is it from here all the way to here? Okay, and if you count through there, you get that the base is going to be 10. So that right there comes out to be 10. So I'm going to say the area is equal to the base, which is 10, times the height. And if you count, the height is from here to here, or 1 unit long, right? So the height is 1. So it's 10 times 1, or the area is going to be 10. Okay, so that's the letter A for number 55. For number B, or letter B, there's no number B. For letter B, you got 3 and then 7. So you count 1, 2, 3, 4, 5, 6, 7. All right there. And then you got 5 and 7. So 5, you're going to count to 5. And then 7 is going to be the same exact height. That's 5 and 7. And then the next one, you got 5 and -3. So right here. Oops, wrong. We got 5 and -3 right here. Okay. Now, and again, if you connect the dots, connect there, you'll see that you are actually missing a point right here. And this point is going to be the point 3, -3. Okay, so if we connect that, we will have a rectangle. Again, we're going to try to figure out the base. Remember, the area for a rectangle is the base times the height. And the base is, how long is this piece down here, right? How long is it from here to here? If you count, that base is 2. And then you're going to want to find out the height. The height is, how long is it from here all the way to here, right? So if you count, that's 7 on top, and then 8, 9, 10. So that's 10. So the base is 2 by the height is 10. So that's 2 times 10, or the area for that rectangle is 20. All right. That's the first one. If you need to go back, review it, rewind this video. Or if you're done, that's good. But I'm going to move on to number 56. 56 says, go ahead and graph each of these lines on the same set of axes, meaning it's on the same graph. And then what's the relationship between lines A and B? And then what's the relationship between lines B and C? So we'll go and do each of these in different colors. So we'll say A is in red. Okay, A starts at +4, so you're going to put a point at +4, and the slope is going to be up 1 and over 3. Okay, so that's where you start, and that's how you move, right? Or the slope. So you start with a y-intercept of +4, and then you move according to what the slope tells you. And the slope says to go up 1, so the change in y is up 1, and the change in x is +3. So we're going to go up 1 and over 3, and you're going to go ahead. You can keep doing that. Up 1 over 3 is going to be the next point. Up 1 over 3 is going to be the next point. And then keep doing the other way around. Down 1 and right 3. Sorry, left 3. Down 1 and left 3, and you keep doing that. Down 1 and left 3. And you'll see that you will actually make a pretty nice line. Okay, so that's the first line. Second line, I'll put it in green if you don't mind. And you start at the 4. That's the y-intercept. So you start at the 4 again. Hey, it's the same place. And then you're going to go ahead and move according to what that number right there is. That's the slope, and that tells you how to move from where you start. And you notice that that number is a -3, but we're going to go ahead and make it into a fraction, -3 over 1. So we're going to be using -3 over 1, as in down 3 and over to the right one time. And you're going to keep that pattern, down 3, right once. Down 3, right once. Down 3, right once. Same thing, up 3 and then left once. Up 3, left once. So if you continue this pattern, you get something that kind of looks like this, or a graph looks like that. Okay, and then lastly, we have this last graph, right? And we're going to start right there at -2, so it's going to start down here. And then this one says we're going to go down 3. So how we're going to move it is with the slope. We're going to go down 3, and I'm going to make it into a fraction over 1. So from that first, where you start, the blue dot, you can go down 3 and over 1. Continue down 3 and over 1. Okay, we're out of space down there, but you work your way up. Up 3 and to the left 1. Up 3, left 1. Up 3, left 1. And then up 3, left 1. And if you graph this, you will see that this also makes a straight line. Okay. So all 3 of these are graphed. Part A says, what's the relationship between lines A and lines B? Well, that's not part A. That's just asking a question. So we want to say, okay, lines A and B are, okay, and if you notice, lines A is red and line B is green, and you notice that it looks like they're at a right angle. That looks like they're perpendicular, but we got to double check that. So to double check it, I'm going to look at the slope of line A, which is 1/3, versus, and the slope of line B, which is -3 over 1. And if you notice, okay, 1/3 and -3 over 1, they're actually reciprocals of each other. Okay, meaning that the fraction is flipped around. And you also notice 1/3 is positive and -3 over 1 is negative. And that's a requirement to be perpendicular lines, is to have opposite, which is positive and negative, and then reciprocal, which is 1/3 and 3 over 1 slope. So we'll say lines A and B are, we'll say, perpendicular. Okay. And part B says, hey, take a look at, or second part of it, doesn't actually say part B, but second part of it says, what about between lines B and line C? So if you look at lines B, which is the green one, and line C, which is the blue one, you can see that they look like they're parallel. Okay. But I'm going to double check it. I'm going to go ahead and write down lines B and C are, right. And in order for lines B and C, the green and the blue one, to be parallel, they have to have the same slope. So line B, the slope is, and again, we already looked at this, -3 over 1. And line C, the slope is, oh, wow, again, -3 over 1. So we know that in order for lines to be perpendicular, they have to have the same slope. And in this case, the green and the blue lines have the same slope of -3/1. So I'm going to say lines B and C are parallel. Okay, that's about it. Okay, last one. Solve for x over 6 equals 5/2 for x, right? Nathan noticed that x is divided by 6. So part A, I says, what can he do to both sides of the equation to get x alone? Right? So in order to get x alone, and then you have a divided by 6, so I'm going to write it down right here. X over 6 equals 5/2. In order to get the x alone, I can multiply both sides by 6, because multiplication by 6 is exactly the inverse or the opposite operation of division by 6. So multiplication by 6 is the inverse operation of division by 6. So if I multiply the left side by 6, I have to multiply the right-hand side by 6. Right? And by doing that, these 6's are going to divide into each other or make a big 1, and we'll be left with x equals 5 times 6 is 30/2, and we know that 30 divided by 2 is 15. But I think that's everything. So what can he do to both sides of the equation to get x alone? First thing you can do is multiply by 6. Okay. Solve for x, which we did. X equals 15. Okay, and this is check your solution in the original equation, meaning that in the original equation right there, x over 6 equals 5/2. We need to plug in 15 in place of the x. So we get x equals 15. That means x literally is 15. Okay, and by doing that, we get 15 over 6 equals 5/2. Right? And in order to find out if they're the same, we need to simplify or reduce 15 over 6. So you look for a number that you can divide both 15 and 6 by. And that number happens to be 3. So 15 divided by 3 makes 5. 6 divided by 3 makes 2. And that's going to be equal to 5/2 also. So that right there checks off. That's your check. Now they're both the same. Okay. Now, last one. We're going to use the same process to solve for this. Okay. So I'm going to move this down a little bit. So it's x over 10 equals 2/5. Right? So I'll put that in purple. So we will need to solve x over 10 equals 2/5. Right? And we're going to use the same strategy. So we're first going to multiply by 10 on both sides. Right? And these 10s are going to cancel out or reduce down to a 1, which means 1 times x gives me x. And on the right-hand side, okay, when we multiply by 10, we're really multiplying by 10/1, which means you only multiply the top numbers together. So 2 times 10 is 20, and then 5 times 1 is just 5. Okay, or 20/5. So your answer is x equals 4. Right, and then you need to put it into the original equation. X over 10 equals 2/5, and you're going to put 4 in place of the original equation. Okay, in place of the x in the original equation, and you're going to go ahead and reduce it down. So 4 divided by 2 and 10 divided by 2, because that's the common divisor. So 4 divided by 2 gives you 2. 10 divided by 2 gives you 5, and lo and behold, 2/5 is equal to 2/5. So that's my check. All right. So that's how you check it off.